So this is my full wave rectifier. This is part 2 of the first video. I got cut off, so I had to start over. Here's the full wave rectifier. You can use this picture to help you build the circuit that we were trying to build for the regulated voltage source. And that was very useful to get past that step. That's probably one of the hardest parts. Here's the simulation on LT Spice. You can see the op amp on top isn't connected to the schematic underneath it. That's because I didn't know how to connect it, so I just used a 10 volt sine wave and I hooked it up to the diode to simulate what we were expecting. And you can see we got an 8.6 volt as expected for full wave rectifier. So that worked out as expected. We got the load resistance on there. Here's a picture of the breadboard with all the wires hooked up. I know it's kind of hard to see, but this kind of give you an idea how I connected my op amp to the full wave rectifier and where that's going to the resistance load on the far right. Now here we have the circuit with a capacitor in for the peak detector, and that's going to show that we can observe now a ripple voltage. This is in waveforms. It's that program I was showing you that we use for the analog discovery, and you can see there's that blue wave is the ripple voltage. So our voltage is always above 6 volts, and that's what we want, and enable to use our Zener diode. A regulated voltage source, we can make it adjustable. We add another op amp to the end, and we can adjust the feedback resistor. The feedback resistor could be a potentiometer, or it could be, that'd probably be the easiest way to adjust the output voltage, by using a potentiometer. And here I'll show you that the Zener diode did work as expected. Here's a schematic on LT Spice of what the final circuit would look like. You can see the op amp on the bottom right. And the Zener diode is located in the middle of the screen right now. That's that D5. That's our Zener diode, and that's forcing a 6.2 volts going into the non-inverting op amp. And again, we're going to have a gain of 2, so we're expecting 12 volts on the output. So here we got all the voltages that we were talking about before. We got a ripple voltage, and here's that blue wave on top says 12.1 volts. That's the output on the op amp. The green wave is 6 volts. That's the input from the Zener. And then the red ripple is going from 8.6 volts to 8.4. And the 9.3 volts is the input voltage into the rectifier. This is on LT Spice simulated. Now the last part here is simulated with waveforms. And you can see that that blue wave is at 6.2 volts approximately for a Zener diode going into the adjustable voltage, regulated adjustable voltage into that op amp. So that is everything. Now we had that wave generator that we had to amplify at the beginning, our 10 volt sine wave. So the yellow wave is showing that, and that's when we had it unregulated, and then our final regulated voltage coming out of the Zener diode was 6.2, and that's that blue wave. So you can see from the beginning to the end where we came. And I believe that is it. Yep. Alright, thank you.